Okay, hi everyone. So this second video, we're going to explore a little bit about pressure in liquids, right? And at the end of this section, we want to discover, right? Discover the formula for pressure due to a liquid, and also to explain some things behind hydraulic systems. Now, so without further ado, right? I want you to let us observe, right, this picture over here. And in this picture over here, we can see that actually, in a column of water, right, in the bottle, when we poke holes in the bottle, what we have here is that, the water is spilling out from the bottle. Okay, so what's one observation that we can see actually is that, at the deeper parts of this bottle, the water spurts out more. Okay, so what can we say from this is that actually the greater the depth at the deeper parts of the bottle, you get a higher pressure, right? So one more time, at deeper parts you get higher pressure. So greater the depth, the higher the pressure. Okay, so why is this so? Because you can think of it in terms of the water, right, having a certain weight. So at the top of the water over here, okay, alright, so at the top of the water over here, most probably you get just the atmospheric pressure, right? But towards the middle of the water, you have the atmospheric pressure plus the weight of the top half of the water. So you have more force acting on that part of the column, so therefore the pressure is higher. And towards the lower part, right, you get the atmospheric pressure on top plus a bigger chunk of water, the weight acting towards that portion. So with more force, you get more pressure at the point, right? So with this, let us transition over to our notes and let us discover, right, how do we get the formula for pressure at the depth of a liquid. So over here, we have a figure shows a column of liquid height h, right, weight w, and a base area a. So first we have volume, right? Volume of a prism will be the base area times the height, right? So this will be the volume of a prism. Okay, then mass actually is gotten from the density formula. So density equals to mass over volume, rearrange, so m equals to density times volume. So with this, let us derive a little bit of the weight. So weight here will be equals to mg, right? Mass times g, right? Mass, we can rewrite mass as rho and v. So density times volume times g. Okay, and just nice over here, we have our rho, and v, we can exchange v and write it as area times h, right, times g. Okay, so this would be the first expression of our weight. Okay, so then to calculate pressure over here, right, over here it will be force over area, or it will be weight over the area, because the force actually comes from the weight of the liquid, right? And then where do we have? We can write this as a rho AHG on top for the weight, right? Do you see this? Okay, do you see why though? Because of this, we just copy and paste here, right? Then the area will be A. Last but not least, we can cancel out our A. So therefore, our pressure is going to be in the liquid is going to be H times rho times G. So what does this mean actually? Is that for pressure in liquid, does the area play a big part? It's not affected by the area. So some key points, some key remarks, alright? So the pressure of a liquid does not, or is independent of area. So area does not affect the pressure of liquid, okay, in the liquid. Okay, pressure is independent of area. Now then, pressure of the liquid, right, is dependent on, okay, dependent on h, meaning the depth of the water or the height of the water column, density of the water, and also rho. Okay, and you see the formula over here, all these are directly proportional. So if your H increase, your rho increase, your G increase, most likely your pressure liquid will increase as well. Okay, now so then it comes to combined science questions like, are we going to memorize this formula? Do we need to memorize this formula? Do we need to apply this when the question comes? My answer is no. So far we have questions in combined science that will ask you to calculate the pressure in the liquid. However, they will be a guided question, so they'll ask you to find volume of water. They'll make you split the thing by parts so that you can actually make full use of the information given there and still be able to do based on the concept of force over area. So that main concept is still the more important thing. This formula here, alright, do we need to memorize? I would say no. Alright, so this one most likely you'll be doing with the force over area style of question. But in order for us to enjoy or to appreciate a little bit of what they do in pure physics, let us take a look at some questions, right? Let's take a look at some questions on the pressure of a liquid. Right, so we have a diver 20 meters below the water surface. So what does this mean? Is that the height of the water above it is going to be 20 meters. Okay, or the depth of the water is going to be 20 meters. Okay, oh yes, before I forget, this is actually the depth of the liquid, right, or the height of the liquid column. Okay, this one over here would be density of the liquid. This one would be your gravitational field strength. So yeah, field strength. Okay, now so let's take a look at the practice B. So the depth of the water is 20 meters. The density is that, so we have another information, the density, right? Density is here, right? So what is the amount of pressure exerted by the water? We also have G. So the pressure of the water, so pressure of liquid, right, is equals to H rho G. So H is 20 meters, rho is the density 1000, G is going to be 10. So this gives us 200,000 pascals. So this answer is C. Because everything is in standard units, so our final answer can be also in standard units. Okay, so this is one example of using the formula H rho G. Okay, so with this, the liquid pressure has many everyday consequences, right? And so let's take a look at the immediate effect of using the height, right? The depth of the liquid. I think that's the biggest impact for us for now. So the base of the dam, right, is going to be thicker. Okay, the base of the dam is going to be thicker because the pressure is higher at the base. Okay, alright, the pressure is higher at the base. So let's take a look at some example over here. So here we have a diagram, alright, showing the lake and so on. Okay, where's my mouse is not here. Okay, so as you can see, the base of the dam over here is going to be thicker, right? Thicker because at the bottom of the lake the pressure is very high, so that's why you need a bigger pressure at the base of the dam, right? With this we also can see that this is how they built the base of the dam, right? At the bottom part over here you can actually see that the base is actually bigger. At the top you don't need such a wide top, right? So engineers will have to figure out what's the pressure below and how much concrete you need below to withstand the pressure so that you don't cause too much leakages. Okay, so next, the second one is that the liquid in a series of connected tubes always have the same level. Right, so let me draw one diagram of what do we mean by connected tubes. So for example, you have a liquid connected via a tube. So the first tube is going to be like a standard tube over here, okay, like this. Okay, so the first tube is going to be a standard tube. Alright, the second tube is going to be a slightly wacky tube over here. So let me draw something like this. Ooh, okay, and then something. Ooh. Okay, like that. Okay, so this will be the second tube. Okay, the third tube. Alright, so let me see. Third tube over here. Okay, maybe like this, like a ball. Go up again, and then another ball. Okay, wait a minute. Another ball. Okay, go up again like this. Okay, right, and then the fourth tube would look something like this. Fourth tube. Okay, maybe let me draw a thinner tube. Okay, like this. Okay, so imagine this part being filled with water. Okay, so imagine this part being filled with water. Oh, I should use another different color though. Okay, imagine this part being filled with water. Okay, so what's going to happen is, right, the water level is going to stay the same across all four tubes. Okay, the water level is going to stay the same across all four tubes, right? So take some time, draw in this diagram over here. Okay, like maybe here. Okay, the last one is going to be until here. Okay, so for across all four tubes, right, the level of water is going to be the same because of the same depth having the same pressure. Okay, so same height, same pressure. Right, what kind of pressure are they withstanding? The atmospheric pressure from the top. Okay, so with this, let me quickly show you one diagram over here. Alright, so this one over here, even you see a spiral, right? Even if you see a spiral over here, the liquid in a series of connected tube has always be the same level. Okay, so this is what we mean by this part over here. Okay. Alright, so with this, we end with part 2 of the video. So the part 2, we mainly discover a little bit about pressure in liquid. Do we really need to know the formula again? We don't need to know the formula because the questions will be guided. However, it will be good for us to be aware that at some point of time, they may test us with these kind of questions, right? So just take note, if you have MCQ, this will save a lot of time for MCQ as well. Okay, so with this, we end part 2. In the next part, we're going to explore the next concept of the liquid pressure is to talk about hydraulic press. So stay tuned.